Hello, this is Yukta Rane and we are studying chapter 1 of ISTQB, that is Fundamentals of Testing, module 1.2 in this video. So before starting with that, let's revise what we learned in module 1.1, that is what is testing. So in module 1.1 we learned about the most important terms of the entire module, that was static testing, dynamic testing, verification and validation. Apart from that, we learned about the difference between testing and debugging and how testing helps stakeholders to take informed decisions. Okay, so moving ahead, let's see what's there in module 1.2. So in this syllabus, as per the little syllabus, why is testing necessary is module 1.2. In that we have 3 sub-modules. Exemplify why testing is necessary, and rightfully so, it is K2. K2 is where we explain examples and understand the real world application of that topic. Now the second one is recall the relationship between testing and quality assurance. So this is our 1.2.2. And the third one is distinguish between root cause, error, defect and failure. Okay, so these 4 are the common misunderstood terms, and we interchange them while for normal conversations, but these terms have different meanings. Okay, so let's start with module 1.2.1 right away. Why is testing necessary? So a part of this answer you already know, because we studied typical test objectives of testing, right? So the testing is necessary to find defects before release. It is very important to find defects before release, as if you don't find the defects, firstly users will be annoyed, as there will be some unexpected failures or unexpected behavior of the system if the defect is not fixed. Secondly, once the user reports the issue, it will be very difficult to build the product from scratch or find out where that defect root cause is, in which component it is. So it is very important to find defects at several stages of SDLC, and the early you find the defect, the merrier. Okay, now the second one is to reduce risk of production failures. The same thing that I explained. So in the production environment, you don't want your product to fail or user to face any inconvenience while using the product. Third one is ensuring quality meets requirements. That is nothing but verification. We have already covered that part in 1.1. And the fourth point is build stakeholder confidence. How exactly will you build stakeholder confidence? By providing the testing results at various stages to allow him to make informed decisions. Okay, and to also allow business representatives to convey the information about any showstopper defects that might cause delay in the release of product. Okay, then provide quality insights for decisions. Same thing that we have studied. So it is basically since we studied the test objectives, that is nothing but the reason why testing is necessary. Okay, so as always, I have prepared some handwritten notes. Let's go through them. I've prepared them by referring to multiple resources, so you don't have to. Okay, so testing is a type of quality control activity. Remember this word very carefully. You will get more meaning of this word once we study the next module, that is difference between testing and quality assurance. For now, just remember that it is a quality control activity. It helps in achieving the agreed upon objectives within the set scope, time limit and the budget. So obviously management has some budget constraints or the time limitations provided by the customers or users. So before that, we have to cover up all the test scenarios. Also, testing activity should not be restricted to test team. So the more amount of people who perform testing activity, the merrier, because it's like if stakeholders can also use their testing skills, that will bring more success to the project. And it is always good to have independence of testing. By independence of testing, you will learn more about this in the upcoming modules of chapter 1 itself. But for now, testing should also be conducted cross-functionally. Okay, so that is what this point means. Then we need to test the associated work products to help identify defects in the software. So we are repeating actually the same thing. We should test the requirement specifications, user stories, which is nothing but static testing, and we should identify defects as early as possible. So we just now saw why testing was necessary. So these points are elaborated versions of it. Basically, you have to identify the problems. It's like a cost-effective way. Why testing is cost-effective way? Because just imagine if your product is released into market without identifying the defects in it, how much cost it will cost, to rebuild the product or to compute or like find out the root cause analysis that led to the defects. Also, at that point in the production environment, we will not be even sure that defect roots to which part of SDLC, which component exactly. So that will be really difficult. So testing also provides a means to evaluate the quality of test objects of SDLC. Now it also helps stakeholders to make informed decisions, and testing should be restricted to contractual, legal and regulatory standards. So if we are performing testing, there has to be some ISO standards on which we perform it, and also we need to carry out audit if whatever processes we are implementing in the testing cycles, if those are being followed properly or not. Okay, some examples where testing should contribute to success. So these are some examples that I have included. Since this is a K2 module, exemplify why testing is necessary, you need to understand the real world application of testing as well. So we can bring more success to the product or software if we involve testers in the requirement reviews itself, which is nothing but static analysis. So this point is suggesting that the testers should know the product in and out, its specifications in and out, so they will know where exactly there will be the scope to find more defects or causes of failures. Second point is, if you have testers involved in the system design, they will not just be able to perform black box testing, which is like testing the system just from the outside. You imagine a system like a black box and you just test input output. No, if you know the product in and out, you will be able to perform white box testing as well, and in case of any defect, you will be able to identify if the defect is caused by software or environmental conditions, and you will be able to explain the defect more accurately to the developer, more precisely to the developer. Now the third point is, similarly you should involve testers while development of the code with developers, so that they form good rapport with the developers and also they get to know the code better. Now testers should support debugging activities. Post debugging, as I said in the previous module, we need to perform regression testing, and the regression testing should be performed by the same tester, ideally who reports the bug, as he will be aware of the features that might get impacted due to the fix. Okay, so this is how in the real world application you will be able to evolve testing more and bring more success to the product. Now this is all about module 1.2.1. Let's go to the next module. Recall the relation between testing and quality assurance. This is K1. So you are just supposed to remember what is the difference between testing and quality assurance, and what is the end output of both of the activities. Okay, so first one, testing. I told you here itself that testing is a quality control activity. It is like maintaining the quality of products. It is to evolve the quality of products by finding more and more defects and by fixing them. So testing is a product oriented approach. It is more of a corrective approach because you are correcting the failures in the system. Okay, now what is quality assurance then? As the name itself suggests, it is quality assurance or assurance of processes which are conducted to carry out testing. So quality assurance is a process oriented approach, whereas testing is a product oriented approach. You assess quality of product in testing, whereas you assess quality of processes in the quality assurance. Quality assurance is more of a preventive approach because good processes is good product. This point is very important. Okay. And quality assurance is both for development activities and testing activities. Okay. And the final test results that come out of testing is used by QA to provide feedback on the development and testing processes both, whereas the test results are used by testing to report defects, okay, to the developers. Also, root cause analysis and retrospectives are used to improve processes for more effective quality assurance. For quality assurance, it is very important to carry out retrospective. What is a retrospective? At the end of, if you have studied Agile before, at the end of sprint, you analyze what went good, what went bad, if something went bad, what was the learning out of it, and what can be further done to improve the quality of products or software. Okay, so this is nothing but quality assurance. Let's come to the last module, relation between testing and QA. This is not the last, second last. So this is just, we saw quality assurance and quality control. It is quality assurance is process oriented, quality control is product oriented approach. So testing is in a way a part of QC activities. There might be more quality control activities as well. For now, we will just remember this. So this was a summary of module 1.2.2, relation between testing and QA. Let's proceed to the okay. So let's start with module 1.2.3, which is distinguish between root cause, error, defect and failure. Okay, so we will understand this with the help of situation, and then we will map those definitions to those respective situations to understand them better, since this is a K2 module where you will be asked questions to apply these concepts in real world application. Okay, so the first one is, let's imagine a scenario where a developer is designing a UI to input some text in a field. Okay, now he designs a code where he forgets that user might input a long string. Okay, so this is a situation that he forgets it. Okay, this is nothing but a root cause. We will talk about root cause later, but let's say he forgets it. It's a human error. Now, because of this situation, he does not handle the limits of the text to be input by user. So user can input any number of characters in the text, right? In the code, if it does if it is not written to handle more length of the string text, then what will happen is it will lead to failure when user will input long text. Okay, so firstly developer forgets, that is a root cause. Then he designs the code such that it doesn't handle long strings, that is error, and that error will error or defect, and that error or defect will lead to failure. Failure in the sense user will not be able to get the expected output when he inputs long text. So basically errors lead to defects and defects lead to failures. Okay, and before errors comes the root cause. Root cause is a situation that leads to error. Okay, but definitely errors and defects are not only the causes of failures. Failures can cause due to other environment factors also, such as radiation or electromagnetic field can also cause failure in the firmware or can lead to defects in the firmware. Okay, now one more important point, where can you find defects? Defects can be found in the documentation, requirement specification as well. The requirement specification is not designed properly. That's why you need static analysis. Second, source code. Okay. So failures can be in source code also. Since if testers are able to know the source code, if they are aligned with the developers, that will lead to more success of that product, because then they will be able to spot out, as a third person perspective, they will be able to spot out defects in the source code itself. And thirdly, it can be defects can be found in supporting build file as well. Build file consists of software, the elements that are integrated into the software, etc. Now, root causes are identified by performing root cause analysis. Okay, and if you find out one defect and if you fix that defect, you might be able to fix all the defects which might occur as a chain effect of that defect. Okay, so that's why finding each and every defect is very important in testing. The more number of defects you find and fix, the more assurance you have or more confidence you have in the quality of the product that you are testing. Okay, so this is basically differentiation between root cause, error, defect and failure. So you don't need to know the exact wordings or definitions of it. Once you understand the concept, that is more than enough for this submodule. So this is where your module 1.2 ends. If you want to revisit some points in module 1.1, you can refer to this video link directly. And if you want to crack this certification, make sure you stay consistent. In case you have any feedback or questions, make sure you drop them in the community chat or in the YouTube comments. I will answer them right away. Thank you for staying consistent.